We introduce perspective fields. Perspective fields are an over-parameterized representation for multiple camera models that works on more diverse images such as those that have been cropped and warped, and can be used to evaluate compatibility between two images when compositing. Perspective fields align better with human perception than existing camera parameterizations, can be used for applications such as sprite recommendation, and can even be used for unique types of image filters. Let's take a look at what makes a perspective field unique. Perspective fields consist of two components, a pixel-wise up vector map and a pixel-wise latitude map. These parameters are redundant by design. We could choose to represent the camera using traditional compact representations such as field of view and yaw, pitch, and roll. However, we found that in practice it is easier to predict our over-parameterized representation using a neural network, and these local parameters correlate more closely with human perception. The principal point is the intersection of the image plane and the optical axis. For many common camera models, this may simply be assumed to be at the center of the image. However, images in the wild often have undergone alterations such as cropping, thus placing the principal point elsewhere in the image. For example, here we have an image which has been cropped. Naively restricting the principal point to the center either produces a correct horizon and incorrect up vectors, or correct up vectors and incorrect horizon. Placing the principal point at the correct location satisfies both. As a result, our work outperforms previous methods on camera parameter estimation when the principal point is in the center of the image, as well as when the image has been cropped. In this work, we present a metric called Average Perspective Field Discrepancy, or APFD. We validated the applicability of APFD by conducting a human perception experiment where participants were shown two images, side by side, that differed only by the camera parameters used to render a 3D object on top. Participants selected one image as better than the other. Our experiment showed that APFD was a better indicator of a visually plausible camera match than were metrics based solely on camera parameters such as roll, pitch, field of view, or principal point. How might we be able to use local perspective fields in order to recommend sprites for image compositing? Given a background image, the user can specify a query to find sprites in a certain category. For example, let's insert a hot air balloon in the cityscape. Here's a whole bunch of ranked recommendations of sprites that might fit. Let's try this first one. I like it, but I really want an example for this side of the image. By selecting this region, we can get an updated ranking and find the sprite we really wanted. Let's finish with one more application, this time an image filter. I have this dramatic shot of a city and we would like to add some ambiance. Using our up vector and latitude predictions, let's make it rain. In conclusion, perspective fields are an overcomplete representation capturing the local perspective properties of an image. They are applicable to a wide variety of camera models beyond a simple pinhole projection and can be robustly predicted with neural networks. Thank you for watching.